A network timeout occurs after a successful payment but before acknowledgement. Retrying now charges the customer twice, causing direct financial loss. Distributed systems rely on at least once delivery guarantees. Every message consumer must assume that any incoming message could be a duplicate. Idempotency ensures that performing an operation multiple times yields the same result as a single execution. It transforms a chaotic retry into a safe recovery. Distinguish between safe methods and idempotent methods. Safe methods do not change server state, while idempotent methods change state only on the first call. Clients must attach a universally unique identifier to every request. This idempotency key serves as the unique fingerprint for that specific intent.
The consumer maintains a duplication store to track processed identifiers. Before executing logic, the system checks if the current identifier already exists. Never use a separate select and then insert. This creates a race condition. Use an atomic upsert or a unique database constraint to handle concurrency. A unique index on the idempotency key column in a structured query language database is the simplest defense. It automatically rejects duplicate entries. When the database rejects a duplicate, the application should catch the unique constraint violation and return the original success response instead of an error. For complex workflows, acquire a distributed lock using Redis or Zookeeper based on the request identifier. This prevents parallel processing of identical retries.
Validate the current state of an entity before applying changes. If an order is already marked as paid, ignore any subsequent payment success messages. Store the initial response body alongside the idempotency key. This allows the consumer to replay the exact same outcome for subsequent duplicate requests. Technical keys are random strings, while semantic keys derive from the data, such as a combination of user identifier and order sequence number. High-volume consumers should use in-memory stores like Redis for deduplication. This minimizes the latency added to each message processing cycle. Set a time to live on idempotency records. Retaining every key forever is unsustainable. Usually, a retention window of 24 to 48 hours suffices.
To ensure atomicity between updating a database and sending a message, write the message to an outbox table within the same local transaction. External actions like sending emails or calling third-party APIs are difficult to roll back. Wrap these in idempotency guards to prevent duplicate notifications. When calling external services, pass your own idempotency key in their headers. Most modern providers use this to prevent double processing on their end. If a request with an existing key arrives but the payload differs, return a 409 conflict. This indicates a key reuse error.
Return a 201 created for the first success. For subsequent duplicate requests, return a 200 OK to signal the task is already done. Idempotent consumers must be deterministic. Avoid using functions that return the current system time or random numbers within the logic, as these change during retries. Commit your message broker offsets only after the idempotency check and business logic are persisted. This ensures that a crash before commitment triggers a retry. If a message consistently fails despite retries, move it to a dead letter queue. This prevents a single poison pill from blocking the entire consumer pipeline.
Retries should follow an exponential back-off schedule with added jitter. This prevents a thundering herd of clients from overwhelming the server after a recovery. Test your system by intentionally injecting duplicate messages into the queue. Monitor the logs to verify that the business state remains consistent and correct. Track the ratio of duplicate requests to unique requests. A sudden spike in duplicates often indicates network instability or misconfigured retry logic in upstream services. Cloud functions are often triggered multiple times for a single event. Use an external storage layer like Dynamo Database to maintain idempotency state across executions.
A robust consumer hashes the request payload and stores it with the key. If a retry arrives with the same key but different data, it is rejected. Include a version number in your entity updates. The update succeeds only if the version in the database matches the version the consumer expected. Adhere to emerging standards by using the idempotency key header in your application programming interfaces. This improves interoperability across different service ecosystems. Distributed transactions across different databases and brokers are complex and slow.
Idempotency is usually a superior alternative to two-phase commit protocols. If a client reuses an old key for a completely new operation after the retention period has passed, the system will treat it as a new request. Log every detected duplicate at the information level. This provides an audit trail showing that the deduplication logic successfully prevented an invalid state change. Each idempotency check adds a database round trip. Measure this overhead to ensure it does not violate your service level agreements for response times. Exactly once processing is typically achieved by combining at least once delivery with idempotent consumers. True exactly once delivery is mathematically impossible over unreliable networks.
Partition your deduplication store based on the idempotency key. This allows you to distribute the load across multiple database nodes as traffic increases. Frameworks like Spring Integration or Apache Camel provide built-in idempotency receiver patterns. Use these proven components instead of writing custom deduplication logic from scratch. Run background jobs to purge expired idempotency keys during low traffic periods. This prevents the deduplication table from growing indefinitely and slowing down queries. In asynchronous messaging, consumers may process messages out of order. Idempotency guards ensure that an older redelivered message does not overwrite a newer state. Clients should only retry on 500 series errors or network timeouts. Never retry on 400 series errors, as these indicate invalid requests. Create dashboards visualizing the health of your deduplication store. Alert on high collision rates or failures in the underlying storage layer to prevent data corruption. Idempotent consumers are a fundamental building block for self-healing systems. They allow infrastructure to automatically recover from transient errors without manual intervention or data cleanup. Implementing idempotency requires discipline across the entire stack. From the client generating keys to the consumer persisting state, each layer contributes to a robust architecture. Before going live, validate your idempotency implementation under high load. Ensure that the overhead of deduplication does not become a bottleneck for your system throughput. Focus on atomic state changes, unique constraints, and consistent response replays. These three pillars will ensure your IT services remain reliable, even in the most unstable network conditions.